Welcome to this video. Today we are going to discuss about bandpass filters. We can define a bandpass filter that it has a pass band between two cutoff frequencies FH and FL. That is, we can define a bandpass filter as a we can define a bandpass filter as a filter which has a pass band between two cutoff frequencies FH and FL, such that FH always greater than FL, that is upper cutoff frequency is greater than lower cutoff frequency. In this bandpass filters, any input frequency outside this pass band is attenuated. That is, a bandpass filter has a pass band in between frequencies uh, FL and FH. Other frequencies other than this frequencies other than within this pass band are attenuated. Bandpass filters are classified into basically they are classified into two types as wide bandpass filters and narrow bandpass filters. That is, bandpass filters are basically classified into two types: wide bandpass filters and narrow bandpass filters. We cannot say that there is a correct borderline between wide band pass filters and narrow band pass filters. However, we can define a filter as wide band pass if its figure of merit or quality factor Q is less than 10. That is, we cannot say a borderline between wide band pass and narrow band pass filters. However, we can say that a band pass filter is narrow band or wide band depending on their quality factor or figure of merit. Uh, if quality factor Q less than 10, we can say that it is a wide band pass filter. Otherwise, it is narrow band pass filter. For Q greater than 10, it is a narrow band pass filter. The quality factor or figure of merit is defined as Q equal to FC divided by BW, where BW is the bandwidth, that is equal to FC divided by FH minus FL. If this quantity is less than 10, we can say the bandpass filter is wide bandpass filter, otherwise it is narrow bandpass filter. This relation is for lower 3 dB frequency. This quantity is defined for lower 3 dB frequency. Where Fc is the center frequency, that is the frequency in between FL and FH, and it is related to FL and FH by Fc equal to root FH into FL. FH is the upper cutoff frequency or high cutoff frequency, and FL is the lower cutoff frequency. Usually, a wide band pass filter is formed by simply cascading a high pass filter and a low pass filter. Uh, if we want to obtain a plus or minus 20 dB per decade band pass filter, first order high pass and low pass filters can be cascaded. Otherwise, if we want 40 plus or minus 40 dB per decade band pass filter, second order high pass and low pass filters can be connected in series. The figure shows here the figure shows the circuit diagram shows a first order wide band pass filter, that is plus or minus 20 dB per decade wide band pass filters. Circuit diagram is shown in this figure and its frequency response is shown here. From the figure we can see that from the frequency response curve we can see that it has a pass band between FL and FH and two stop bands between two stop bands, first in the lower frequency range and the second one in the high frequency range, because here we have cascaded to one high pass filter and one low pass filter. Next one is narrow band pass filters. In the previous case, that is in the case of wideband pass filter, we have seen that in order to get a pass band between upper cutoff frequency FH and lower cutoff frequency FL, one high pass and one low pass filters are cascaded together. But in the case of narrow band pass filters, we have obtained the pass band or a band pass filter simply by using one op amp. Um, And the peculiarity of this narrow band pass filter is that it has two feedback paths. In all the other previous low pass filter, high pass filter, second order low pass, second order high pass, and wide band pass filters, we have used only single feedback path. But in the case of narrow band pass filters, we have two feedback paths. So this narrow band pass filter, this particular circuit diagram is known as multiple feedback filter. And the other difference is that in this case, the input is given to the inverting input terminal of the op amp. In all the other previous situations, we have given the input voltage to the in non-inverting input terminal. But in this narrow bandpass filter using multiple feedback paths, we have given the input to the inverting input terminal of the uh, op amp. So it is so this narrow band pass filter is based on is working in inverting mode. Usually the narrow band pass filter, we have said that its figure of merit Q is greater than 10. So it is designed for specific values of center frequency Fc and Q. That is for designing a narrowband pass filter, we have to first of all specify the center frequency Fc and the quality factor Q instead of giving lower cutoff frequency and upper cutoff frequency. Uh, in order to design a narrow band pass filter, we can simply choose the capacitor values C1 equal to C2 equal to C, and the resistor values are obtained as R1 equal to Q divided by 2 pi Fc CAF, R2 equal to Q divided by 2 pi Fc C into 2Q square minus AF, where AF is the closed loop gain of the circuit, and R3 equal to Q divided by pi FCC. And here it is a narrow band pass filter. So narrow band pass filter. So its center frequency is center frequency. By giving the center frequency, we have to design the narrow band pass filter. And AF is the closed loop gain, which is defined at the center frequency. And it is given as AF equal to R3 divided by 2R1, because here we have two feedback paths, so the gain is different from the inverting is different from the inverting amplifier. So here it is given as AF equal to R3 by 2R1, and the condition uh, and the gain should always satisfy the condition AF should always be less than 2Q square in order to get this particular R2 positive. These are about narrow wide band pass filters.